Okay, 5-2. Multiply and divide big, messy fractions or rational expressions. What do you remember about just multiplying fractions? Was it easier to multiply fractions or add fractions? Multiply, because you don't have to have common denominators, right? So this section, not too bad, because I'm multiplying and dividing fractions. So when I multiply fractions, I remember it's top times top, top times bottom, right? Multiplying fractions, that's no problem. And when I divide fractions, what do I have to do before I start? Yeah, flip that second fraction. Great job. So if I flip the second fraction, then I go ahead and multiply. Division is really multiplying by the reciprocal of the second fraction. Okay? So those are two important rules. We're going to use those here. Now, if I told you to multiply something like 9 over 25 times 15 over 27, would you just say, okay, multiply? Would you say 9 times 15? I mean, you could, but could you do a step first that would make your life easier? Yeah. You could cross-cancel diagonally, right? Or straight up and down. If you could divide both of these by 3, you could do that, that's okay. Or you can do it diagonally, too. So, let's do this. 9 goes into itself 1 time, and 9 goes into 27 3 times. 15 divides by 5 3 times, and here 15 divides by 5 5 times. Now I have 3 over 3, right? So that's dividing by 1, or dividing by 3 leaves with 1 and leaves with 1. Now you can multiply top times top, that's 1 times 1, and bottom times bottom is 5 times 1. 1/5. You could have gotten that if you just took 9 times 15, got a giant numerator, and then 25 times 27 and got an even more giant denominator, and then reduce, till you get to 1/5. But this is so much faster and easier, right? Again, you can cancel diagonally either way, or you can even cancel straight up and down. The only thing you can't do is cancel horizontally, right? It's like shaving. I don't remember the movie, but Michael Keaton made a movie a long time ago where he was diagnosed with cancer, and he was leaving a video for his unborn son about all the things that father would tell his son. One of the things Michael Keaton said is, when you shave, it's okay to shave this way, right? Shaving this way, up and down, good. Never shave sideways. Never the sideways shave, right? That's very bad. You'll be sorry. So the same thing happens here. You can go this way, that works. Straight up and down also works, but never the sideways shave. It's not allowed. Okay? You cannot cancel horizontally. By canceling first, then my answer is already reduced, and it's way, way easier. We're going to apply that same concept to multiplying expressions. Let me do an easy one to start with. In case this is hard to see in the video, this is negative 7x squared over 5y times 3y to the 5th over 14x squared. Okay, when I look at this, I see some numbers that jump out to me. This negative 7 and 14 jump out at me, so I'm going to cancel those. Negative 7 goes into it, 7 goes in there negative 1 times, and in here 2 times. What else do you see? The x squareds, right? This guy has an x squared. This guy has an x squared, so those go away. Boom. And what else?
Y.
You have at least one y. If it helps you to write a little 1 right there, you can do that. This whole thing is going to cancel, so I draw a line that goes through the exponent and the y. And up here, I have 5 y's. Maybe I'm visualizing y times itself 5 times, y times y times y. One of those is going to cancel with this, and I'll have 4 left. So I'm going to just cancel off the exponent and write a 4. So the difference in what I've done here is I've eliminated the whole y, because I canceled all of those off. And here, I just reduce the exponent to 4. have negative 1 times 3 times y to the 4th. I'll write that step out. You might do this step mentally, but I'll write it out tonight. 5 times 2, and my variables are all gone. Negative 3y to the 4th over 10. Perfect. And again, you could have just multiplied top times top and bottom times bottom. That would have worked okay, but you would have had a large number that you would have had to cancel. Maybe that's a little bit harder. Here's another example.
Is that 5x squared?
5x squared, yes. Mm-hmm. Kind of crazy too. All right, now if you were super brave, you might just take this times this, top times top. But you can imagine you're going to get a great big mess, right? Same thing down here, bottom times bottom. Wow, that's going to be a huge mess. So instead of that, let's factor and see if there's maybe anything that could be factored off. This numerator, I can factor a 3 out front. That'll be 3 times x plus 1. This denominator, I can factor off a 5 and an x. So that's 5x times x minus 1. Oh, so close. Did I write it down though? Nope. Times. This is going to factor over here, I suspect. The only possible factors for negative 3 are 3 and 1. And I want it to add together to be positive 1. So I don't want to put the 3 here, because if I put the 3 on the outside, then it's 2 times 3. That'll get too big too fast. So I'm going to put that heavy one in here and put the little 1 out here. I want it to be positive on my biggest number so that my middle term is positive. So I'm going to make this addition and this subtraction. That gives me a positive 3 and a negative 2. Those add to a positive 1, so that works. And then this last denominator, 4x squared minus 9, it's 2 terms. I notice that this is 2 times 2 and this is 3 times 3, right? So that's going to be one of those perfect squares, 2x plus 3, 2x minus 3. All right, let's start chopping. 2x plus 3s are an obvious go. That's going to make life easier. What else?
X minus 1.
X minus 1s can go. Right? So it's okay to cancel diagonally like that, and it's okay to cancel straight up and down. Right? If we can reduce that single fraction, that's okay. This x plus 1 doesn't have anybody to cancel with. My 5x and my 3, those I don't have anything to cancel. So let's rewrite what we have left. 3 times x plus 1 times nothing, or 1 and 1, over negative 5x times 2x minus 3. I'm double checking here, before I put a box around my solution, I'm double checking that I didn't miss anything. Right? Just like in this final answer, every once in a while I miss a cancellation. If I miss one, then this might have come out to be 2 over 10. And I think, oh, I'm not quite, I could reduce that. I missed one. So I'm looking at this before I circle it and saying, is there anything here I've missed? And it doesn't look like there is anything that could cancel. So I think we're good. Here's my solution. This has the same value as this times this. We worked it out, multiplying two expressions. There's no equal sign where I'm solving for x, just multiplying two expressions. Dividing fractions is the same way. If I have a over b divided by c over d, when I divide fractions, I'm going to multiply. This fraction doesn't change, but I multiply by the reciprocal of that. That's just exactly what Jose reminded us of. Dividing fractions is actually multiplied by the reciprocal. I think you guys remember that. So we have exactly the same process, only before we're all the way done, we have to remember that we have to flip the second one over. I'm going to do one example here, and then I'm going to turn you loose tonight. In case this is hard to read on the video, 2x squared minus 11x plus 5 over 5x minus 25 divided by 4x minus 2 over 10. All right, first thing we want to do is factor. Actually, maybe before we factor, we should just flip it over. It doesn't really matter if you factor all the pieces and then flip it over, but because it's so easy to forget to turn the second fraction on its head, I think we should do that first. So I'm going to rewrite this as 2x squared minus 11x plus 5 times 10 over 4x minus 2. So looking at this, I can kind of imagine that the 10 will cancel a 5 off of here, because I can factor a 5 off of this, right? And I can factor a 2 off of this, and then I will have 2x minus 1. And I betcha the 2x up here will be a minus 1. Like, I betcha that these two will have a common factor. Let's see what happens. Factoring 2x squared is going to be 2x and x. Factoring 5 has to be 5 and 1, and I want to get all the way up to 11, so I'm going to put the 5 on the outside so that these can go together. And it's a plus 5, but a minus 11, so those are going to be minus minus. 2x minus 1 times x minus 5. Gives me a minus 1, these two give me a minus 10, that adds together to be negative 11. In the denominator, I can factor off of 5, that gives me 5 times x minus 5. Double check by redistributing, 5 times x and 5 times 5, that works. Times 10 over 4x minus 2, I can write that as 2 times 2x minus 1. Factor off a 2 from that second denominator. Okay, we've got some things we can cancel.
2x minus 1.
Perfect. Let's get rid of that messy guy. He goes away. 2x minus 1 is gone.
X minus 5.
X minus 5. Perfect. Gone.
5 and 10.
5 and the 10. So 5 goes into there 1 time. 5 goes into 10 2 times. Okay? Anything else? Or are we pretty good there? What do I have left? This is a 1. This is a 1 times 2. So the only thing I have left here is the 2. 1 times 1 times 2 times 1. So this is also a 2. So here's an example where I get to the end and I get 2 over 2. And this I know reduces to 1. And when I see that, I might have thought, Oh yeah, 2 and 2. I could have just said cancels to 1, cancels to 1. You could have reduced these two 2's, right? 5 times 2 would have canceled with 10. Either way, we end up at 1. It doesn't really matter. The important part is you get the big chunks, right? The numbers sometimes aren't that bad. So multiplying fractions, factor the numerators and denominators and cancel what you can. Dividing, turn the second one over. Okay, this was flipped over and changed to multiplication, and then we factor. It's a good idea, I think, to flip the second one first because it's so easy to forget that. It's obvious if you forget it because you think to yourself, gee, I wish the 2x minus 1 was on the other side, and then you might think, oh yeah, I forgot to flip it, right? The other thing that I was thinking to myself is I knew that this was going to factor off at 2, and mentally I can visualize this as 2 times 2x minus 1, right? This one factors pretty easily. I can kind of do that in my head. So when I knew that this parentheses was 2x minus 1, that made this easy to factor. Because when I knew one of these was 2x, I'm thinking to myself, if this is a 2x, and this is a 2x, right? And my factors of 5 are 5 and 1, it only makes sense that they're going to make this be a minus 1, right? So that this and this will be the same. So when I'm factoring this guy, if I have this as kind of a guide, then chances are this is going to factor as 2x minus 1 in one of the parentheses. Not always, but, you know, a lot. It happens a lot. What questions do you have about multiplying or dividing or simplifying our first step tonight? All okay? The hardest part of this is the factoring, right? And we said when we learned factoring, practice it, practice it, practice it, because you need to be able to look at this and get to here really quickly, right? And if you look at this and try to factor it, and I know a lot of times that's in the margin, it doesn't happen just instantly, but if that's really, really hard, then these problems take a long time, and you feel like, you just have to stay in the zone for such a long time to get through a problem that they get exhausting. So if factoring's really hard, these are hard. But if you've kind of gotten up to speed with factoring, then these are okay. And the more you do of this, the easier factoring gets. Because there's some of those pairs that you start to recognize, like the patterns become more obvious the more times you factor them. Okay. Since you 3 champions were here tonight, I'm going to let you go. Okay? So for next week, you have a textbook test. A little different than what we've done before. It's still a take-home test, but not multiple choice. You also have the homework from 5.1 and 5.2, 4.7 we completed together, so you've got that checked off. Next week when you come, you're going to, don't forget to leave me your Chapter 4 quiz. Perfect. Next week you're going to have the test completed and all of Chapter 4's homework ready to turn in.
What's the assignment? 5.